Good morning, students. Today we will discuss about gear train in the subject theory of machine. So, at first we should know what is gear train. So, the gear train, two or more gears are made to mess with each other to transmit power from one shaft to another. Such a combination is called gear train. So, what does this term signifies? That more than two or more gears, that means we have either two gears or we can have more than two gears, and both gears, each gears are meshed with each other, that means each gears are connected with each other in such a way that each gear can transmit power to another gear, and through that it can be transmit to through shaft to the extreme position where the power is required. That means that for the transfer of power from one shaft to another shaft, there are more number of gears are being arranged in between that, and they are meshed in such a way so that they can transmit the power. So this whole arrangement is known as gear train. This is known as gear train. Why? Because the gears are used to mesh with each other for the transmission of power. So simply, in simple words, we can say that when more than one gears are arranged in such a way that they transmit power from one shaft to another, so that combination is known as gear train. Gear trains are mainly divided into four types. That are, first one is simple gear train, next one is compound gear train, third one is reverted gear train, and fourth one is epicyclic gear train. These are the four type of gear train which are being used for the transmission of power from one shaft to another shaft. The first one is simple, compound, reverted, and epicyclic. Note it down, and then we will discuss one by one from simple gear train to epicyclic gear train. So the first one is simple gear train. What is simple gear train? When there is only one gear on each shaft, then the arrangement is known as simple gear train. This is the simple one line that is been focused for simple gear train. That is, there will be one shaft in each gear. That means there are two gears being arranged and two shafts, and each shaft having one gear. That means if the shaft is having one gears and there are number of shafts and each shaft are having single gears, then that arrangement will be known as simple gear train. So the given figure will justify you how it works. That is, there are two shafts, shafts 1, shafts 2, and there are two gears, shaft 1 and shaft 2, and each shaft having each gear. That is, the shaft 1 is having with gear mounted on that is the gear 1, and on shaft 2 gear 2 is being mounted. The gear 1 is known as driver pulley, that is being driven by some power output, and the gear 2 is known as driven or follower pulley, that is being driven by the driver pulley. So the speed ratio for this arrangement will be given by N1 by N2 equals to T2 by T1. What is where N1 is the speed of driver pulley, N2 is the speed of driven pulley, T2 is the number of teeth of driven pulley, and T1 will be the number of teeth of driver pulley. So you can say that there will be more arrangement. Another arrangement can also be possible for simple gear train. That is how? That is, if there are three gears and each gears having single amount of shafts, then that will be also a possible case of simple gear train. The main condition for simple gear train is only what is each shaft should have one gear. That is the prime condition. The number of gears will not be limited to 2 or 3. It can be infinite. But the main condition for simple gear train is what? That one gear on each shaft. So I hope you will understand what is simple gear train. You should remember this formula as it will be helpful for you to solve the numericals. So coming back to the next one, that is compound gear train. Now the next topic is compound gear train. So what is compound gear train? When there are more than one gear on a shaft, then the arrangement is known as compound gear train. Simply just reverse case of simple gear train. In simple gear train we have single gear on each shaft, but here on each shaft we can have more than one gear. We can have one gear, but we can have case of more than one gear. Then that type of arrangement is known as compound gear train. That means, once again I am telling you that when there is an arrangement in which in a single shaft there is a possibility of having more than one gear, then that type of arrangement is known as compound gear train. For that, we can understand through this figure that there are 1, 2, 3, 4, 5, 6. 6 numbers of gears are arranged, but only we have 1, 2, 3, 4 shafts. That means for number 1 gear we have one shaft individual. For number 6 gear we have one shaft individual. But for gear 2 and 3 we have a common shaft, and both for 4 and 5 gear we have a common shaft. That means in a single shaft more than one gears are being connected. So that's why this type of arrangement is known as compound gear train. So we can easily justify that the number 1 gear will be the driver pulley and number 6 will be the driven pulley. And in between those gears, that is 2, 3, 4 and 5 are known as compound gears. So number 1 is driving number 2 gears, number 2 is driving number 3. Similar to that, 4, 5 and 6 each are meshes with each other, so that each can transmit power from one gear to another, and through that the gear 1, the power will be transmitted into number 6 gear. So while calculating, we can calculate the speed ratio. That will be the for gear 1 and 2, the speed ratio will be N1 by N2 equals to T2 by T1. This is the simplest formula which we are going through the previous cases. Then the gear speed ratio for the 3 and 4 gears will be N3 by N4 equals to T4 by T3. Similarly, for the 5th and 6th gear will be N5 by N6 equals to T6 by T5. This is the formula based. So on multiplying each factors, we can get N1 by N2 into N3 by N4 into N5 by N6 equals to T2 by T1 into T3 4 by T3 into T6 by T5. This is the simplest multiplication. This into this into this. Simply multiply all. So we can see that N2 and N3 will cut each other and N4 and N5 will cancel each other. How can you say that it will cancel each other? Because the gear 2 and gear 3 are mounted in a common shaft. Similarly, gear 4 and gear 5 are mounted on a common shaft. So if 2 gears or more than 2 gears are mounted on a common shaft, then the speed of both these gears will be same. That's why N2 and N3 will cancel each other and N4 and N5 will cancel each other. So upon solving, we can get N1 by N6 equals to T2 into T4 into T6 by T1 into T3 into T5. That is, the speed ratio will be given as the product of teeth of driven pulley to the product of teeth of driver pulleys. So I hope you will understand what is compound gear train. So next one is reverted gear train. So now, what is reverted gear train? When the axis of first gear, that is first driver, and the last gear, that is last driver, are coaxial, then the gear train is known as reverted gear train. That means coaxial means that are both are in a common axis. Coaxis means what? What do you mean by coaxis? Coaxis means common axis. So that is when the first gear, that means the first driver pulley, and the last gear, both are arranged in such a way that both are connected to a common axis, then that type of arrangement is known as reverted gear train. That means the first axis and the last axis will be arranged in such a way that both will arranged in a common shaft. This figure will justify what about this statement, that is, there are 4 gears, 1, 2, 3 and 4. 1 is the driver pulley, obviously 1 will be the driver pulley and 4 will be the driven pulley. So the driver pulley is one pulley, 1 is connected to 2, so 1 is indirectly rotating the second gear. Similarly, the third gear is a compound gear with the second, so indirectly third will move and third will run the fourth pulley. So the gear 1 and gear 4 are hence connected to a common shaft. I will justify once more that the gear 1 is running the gear 2. Since gear 2 and gear 3 are compound gears, So both will run at a common speed, and since gear 3 is connected with gear 4, so gear 3 will run gear 4 drive. So by this arrangement we can easily say that gear 1 and gear 4 are connected to a common shaft, that is coaxial shaft. So this type of arrangement are known as reverted gear train, where the driver pulley, that means first driver pulley and the last driven pulley, both are connected with a common shaft. That is, the speed ratio will be calculated by the formula N1 by N4, and that will be equals to the product of number of teeth of the driver pulley by the to the ratio of number of product of teeth to the driver pulley. These are the number of teeth of driven pulleys, and these are the number of teeth of driver pulleys. So T2 into T4 by T1 into T3, and speed ratio will be given by the formula N1 by N4 equals to T2 into T4 by T1 into T3. I hope you understand this case also. Now coming back to the last one, that is epicyclic gear train. So the last one is epicyclic gear train. So what is epicyclic gear train? When one or more gears move upon and around each gears, then the arrangement is known as epicyclic gear train. In the figure you can see that there are one gear A, another gear B, and in between that gears an arm is been fixed, that is C, and the arm is here fixed, so the gear B can move around and upon gear A. So this type of arrangement is known as epicyclic gear train, in which one gear can move upon and around another gear. So here, if arm C is not fixed, then arm C and gear B both will move around and edge upon gear A. But if gear A is fixed and arm C is also fixed, then only gear B can move upon and around gear A. So when one gear can move upon and around another gear, then this type of arrangements are known as epicyclic gear train. These type of gear trains are highly used for transmitting high velocity ratio with moderate size gears. When we have limited space and we have to transmit high velocity ratio, then we use epicyclic gear train. The best example for understanding epicyclic gear train is your scooty. Most of the students use scooty for the transportation purpose. So as you all know that in scooties there are no neutral manual gears, so in between their automatic gears are being used in there. So epicyclic gear trains are used for the transmission of automated gear. So the best example of practical implementation of epicyclic gear train is your scooty. So for calculating the velocity ratio of a epicyclic gear train, we have two different methods, that is tabular method, another one is algebraic method. We can use these two methods to solve the velocity ratio of epicyclic gear train. So by using these two methods, we will discuss on the next class about these two methods, how to solve the velocity ratio of epicyclic gear train. I hope you understand this topic also. So today we covered the gear trains, that means 4 types of gear trains, that is simple, compound, reverted and epicyclic gear train. Thank you very much all students. Thank you. We will see the next one in the next class.